So hi everyone, welcome to my YouTube channel. Here in this video I am going to explain you about the solar panel in parallel combination. So in the previous video I have explained about the solar cell efficiency and fill factor, and also solar panel in series combination. So in this experiment I am going to explain you about solar panel in parallel combination. So before going to start, first you should know how to make the circuit connection to perform this experiment. So first here the apparatus required are the solar panel. You can see here we have considered these two solar cells which are connected in series parallel combination. So here are the positive and negative terminal of these two solar cells. So if we make combination, that we call solar panel in parallel combination. Here is the ammeter, and this is the resistance box, and this is digital multimeter. These are the connecting wires, and this is a 100-watt bulb. So these are the apparatus we require. So as we know here, the aim is to check the efficiency of the solar panel for parallel combination and study the IV characteristics. So theory, if you want to understand, just read the solar cell, how it is going to convert the light energy into electrical energy. So already if you read the theory, that is helpful to understand how to do this experiment. Efficiency and fill factor formulas you should know, and the procedure I am going to explain you, and the formulas required here they have written: input power watt into area divided by 4 pi d square. So whatever the bulb you are using, you should write the watt of that bulb. Efficiency P max divided by P in into 100. Fill factor I max into V max by ISC into VOC. And observations you should write here. So number of cells in parallel plane solar panel, n is equal to 12, because we have considered here two cells. If you count 6 plus 6, 12, n is equal to 12. So the intensity of solar radiation, that would be here 100-watt bulb. Area of the cell, length into breadth. If you take one cell, it is having the length 2.5 and breadth 1.6, so 4 centimeters square. For one cell there are 12 in number, so area of the panel you can calculate around, it would be 12 into 4, 48 centimeters square. So distance between filament and bulb, how much distance you are taking, note down that. Short circuit current, that is here 80 milliampere. So even without applying resistance, that would be short circuit current 80 milliampere, and the voltage must be 0. Short circuit current, you have to write 80 milliampere. Open circuit voltage, you have to apply here infinite key. Then you should note down the voltage across DMM, that is around 1.5. So this is what open circuit voltage. So they also got around 1.6. So 1.5 or 1.6 volt you should write. So this is the observations for the solar panel in parallel combination. So nature of graphs, current versus voltage you have to draw, and this is for input power versus log R resistance. There are two graphs, and the circuit diagram you can see. According to this diagram you have to make the connection. So here you can see positive and negative terminal. Positive is red, negative is black. So first connection here, from positive to positive we should make the connection, and negative to negative. So positive to positive, negative to negative. So from positive to positive, one common connection between ammeter, and then negative of the ammeter to the resistance box, negative of the ammeter to the resistance box, and the another end of resistance box to the positive, another end of the resistance box to the negative terminal, that we have made the common junction, negative terminal. So common junction is here. So then across this old emitter and resistance box, we should connect DMM. So here across emitter and resistance box, we have to connect the DMM. This will complete the circuit diagram for solar panel in parallel combination. So next you can take the reading here. You have to apply resistance in the increasing order 10 ohm to around 140 ohm. For 10 ohm, once you apply, how much current you will get should note down, and corresponding voltage. Then you can calculate power and take the log of R in the last column. Then you can go for plotting the graph. So first reading I will show you here. If we apply 10 ohm, 5 directly, 10 ohm. So here the corresponding current is about, for this, so the voltage is around 0.6 volt. Then you should write the current around 80 milliampere or 82 milliampere, and the corresponding voltage here now it is 0.7. So like that, here how much they have written. Like that you have to apply the resistance in the increasing order and note down the current and voltage, calculate power and take the log of R, then go for the calculation. So efficiency they got around 7.37%, and the fill factor, after plotting the graph you will get the P max. Use that P max in the calculation for the efficiency. P in using this 100 watt bulb you should calculate. Then fill factor they got around 0.6. ISC in the observation we have written short circuit current and open circuit voltage. Use that and calculate fill factor. So at the end you can write the result here. So, and one more graph, log R versus input power. So if you plot this graph,